It's Sunday, 19th of January, and we are awaiting SpaceX's launch escape test in just under 17 minutes and 8 seconds. The test today is to demonstrate the effectiveness of our launch escape system. Now we are currently go for launch from pad 39A at Kennedy Space Center at 10:30 a.m. Eastern Standard Time. Thanks for joining us. I'm John Isberger, Falcon Principal Integration Engineer here at SpaceX headquarters in Hawthorne, California.
And I'm Marie Lewis with NASA Public Affairs. The purpose of today's test is to demonstrate Crew Dragon's ability to safely fly astronauts away from danger and separate from the Falcon 9 rocket during an in-flight emergency. Now, SpaceX's launch escape system is a first of its kind, with its 8 Super Draco thrusters built directly into Dragon to push the spacecraft away from Falcon 9 in case of an emergency. You can think of it as a rocket on top of a rocket.
Now, in order to test our launch escape system, which is integral to the Dragon spacecraft you see in front of you on the video, we will be simulating an emergency with Falcon 9 at about 84 seconds into flight. This could be a few seconds early or late, as Dragon waits for Falcon 9 to reach a specific velocity before initiating the escape. Now, before Dragon separates and fires its Super Draco engines, it will command Falcon 9 to shut down its engines as part of the escape sequence. Because Falcon 9 is then unpowered, we are expecting the launch vehicle to fully break up at some point, which should create some particularly interesting views.
For sure.
Now, it's not every day you get to see something like that, so we're going to do our best to bring it to you live as it happens. But a reminder, with the weather and the clouds, we're going to try to find the views that are best. And to be very clear, this is all part of today's test. Within the context of this test, the views that you will see will allow us to validate the effectiveness of our launch escape system.
And we're hoping for some very exciting views, but the whole point of the test today is the next step in our multi-year efforts to fly astronauts again from U.S. soil. It's part of NASA's Commercial Crew Program, and it's a partnership we have with SpaceX and Boeing. But this is not the first time we are putting Dragon's launch escape system to the test. If you remember, back in 2015, SpaceX's pad abort test demonstrated Dragon's ability to escape from the Falcon 9 in the event of an emergency on the pad before liftoff. And the Super Dracos in the launch escape system on today's Dragon capsule you see there were successfully static fired this past November.
And in addition to the test that you just mentioned, SpaceX also flew a full uncrewed demonstration mission to and from the International Space Station last year with its Crew Dragon vehicle. Now, this was a full end-to-end test of the entire Crew Dragon system, validating that our upgraded Crew Dragon spacecraft could safely dock with the space station. And in addition, our team has conducted over 700 tests on just the Super Draco system alone. Really looking forward to seeing those perform in today's flight.
Absolutely. And if all goes well today, the next big milestone will be to launch astronauts, as we mentioned, to the International Space Station. That's part of what we call Demo 2 or Demonstration Mission 2.
Now, we're currently just inside of T-minus 13 minutes and 45 seconds and counting down. Now, weather's been a watch item the last couple of days with rough seas, sustained winds in the recovery area. We had to scrub yesterday. We're also still listening. They're evaluating constantly the weather in the splashdown area right now as we're doing the webcast. Now, we do have a 6-hour window today in case we need to wait for better weather or less cloud cover. We've obviously used 2.5 hours of it already, but right now we think this is our best opportunity. Now, if the weather does not cooperate today, we are preserving tomorrow as a potential backup. Now, as a reminder again, this is not a typical launch. We're purposely testing Dragon's escape system under the most extreme conditions. So while we want everything to go right today, we are prepared if everything goes wrong.
And if that does happen, that's the whole point. This is exactly why we test. We want to see if there's any potential issues, and we want them to happen now so we can address those before we put astronauts on board. And speaking of astronauts, we have NASA's Darrell Nail at Kennedy Space Center in Florida. That's where the test is taking place this morning. And he has more about what those very first astronauts assigned to fly Crew Dragon will be paying special attention to this morning. Darrell?
Yeah, good morning, John and Marie. It's a pretty nice day here at the Kennedy Space Center in Florida. You can see behind us here on the lawn, some of the media have gathered to shoot this launch. And of course, the countdown clock, the iconic one, they're counting 12 minutes until launch. As you mentioned, the first crew members assigned to fly Crew Dragon are NASA astronauts Doug Hurley and Bob Behnken. And they have the most, you could say, invested in the outcome of this test flight. Right now, they are just a few miles away from Launch Pad 39A, which is just behind my left shoulder here. They're in the SpaceX firing room inside the Launch Control Center, where they will closely monitor today's flight abort test. Now, right now, they've been training up until this point, training hard with NASA and SpaceX so they can understand every aspect of Dragon's systems, their spacesuits, and how to respond in a variety of potential emergency scenarios, including an escape from a Falcon 9 rocket in the middle of flight. The end result of that could be an early splashdown in the Atlantic Ocean. Now, both astronauts told us what they will specifically be looking for during today's test flight.
I think both of us are really excited that the inflate abort test is about to happen. You know, we kind of view that as the graduation exercise, like a lot of folks do on the NASA side, to make sure that we're really confident that we've got a good plan and good procedures in place for pulling that mission off. And so I'm excited that we're this far, and I know once it's behind us, you know, we'll be the prime Falcon 9 Crew Dragon crew.
What we want to see from this test is just an end-to-end success. And so, you know, another successful launch of the Falcon 9, and then to see the Super Dracos work.
I think that's a really good point. I think getting the NASA team and the SpaceX team on the same page, kind of going forward and kind of walking through all the decisions that you have to make for getting ready for this flight, I think is a big milestone as well, because it's the last launch associated with us before we ride that rocket.
Yeah, that's very true. It is. It's kind of the final exam, so there's a lot riding on it, but also I think it's a culmination of a ton of work from everybody in NASA and SpaceX to get to this point.
I'm just really proud that the team is trying to pull off something so critical from a safety perspective. You know, if we needed to escape off of the rocket, to have that system demoed before we would actually use it is pretty cool that folks are making the investment to make that happen.
We feel really excited about kind of the progress that SpaceX and NASA have made to this point, and this kind of shows us that we're getting really close to our flight. So to see all these capabilities all put together, all the teams together, and to be able to launch this vehicle, it's just a huge boost of confidence.
Now, there's an interesting human side to Doug and Bob's story. They're not just crewmates, but they're also friends who have spent a lot of time together over the years. Both graduated from the same astronaut training class in 2000. Both flew on the space shuttle. Both are married to astronauts, and they were in each other's wedding. John and Marie, back to you.
All right, thanks, Daryl. You're taking a live look now. This is inside SpaceX's firing room 4. That's where Bob and Doug are sitting today, along with the NASA and SpaceX teams, following along today's test. And this past Friday, they completed what we refer to internally as a dry dress rehearsal. We saw some video of that during Daryl's segment. And this is where the astronauts, along with the SpaceX and NASA teams, walk through those steps that they'll take before they get on board for Demo 2. We saw them suit up, and that is really exciting stuff, especially that was the first time we saw them suited up walking out of the astronaut suit up room, and so really looking forward to doing that for Demo 2. Let's take a quick look now at Crew Dragon. It stands almost 27 feet tall from the bottom of the trunk to the top of the nose cone. And Crew Dragon is composed of two main elements. The capsule, that top portion, is designed to hold crew and pressurized cargo, and it has an unpressurized section known as the trunk that's down below. For today's test, much of the exciting work is going to be done by the Dragon's 8 Super Draco engines we talked about, built directly into the capsule.
Now, to give you a sense of power, when fired together, the 8 Super Dracos can move the spacecraft a half a mile in 7.5 seconds. So from a standing start, the Super Dracos accelerate the spacecraft to a speed of 436 miles per hour. That's a lot faster than a catapult launch from an aircraft carrier.
I know, and it's hard to imagine just moving that fast. I was trying to get a feel for it. So I did a little math, and it's about 3 times faster than takeoff on a commercial plane, if you can imagine that. In fact, one jetpack assembly, which consists of 2 Super Dracos, produces more thrust than an F-16 fighter jet at full afterburn. So, John, if you were to put that, strap that to your back, you would break the sound barrier in under half a second. Not sure you'd want to volunteer for that.
I'd probably break something else, too. So that gets us through the major test objective today, Dragon separating from the Falcon. Several minutes later, we will deploy drogue parachutes, followed by the 4 large main parachutes. You'll see the main parachutes partially open at first if we've got video, then fully open. These will then control the descent of the Dragon capsule softly into the Atlantic Ocean.
And while that vehicle that you see on the pad looks like a typical Crew Dragon spacecraft from the outside, if you had a look inside, you'll see that the interiors have been stripped down, and there it is. We do have a look inside for you. The cabin has no interior panels except for one on the ceiling, and there's no control panel in there for this test. Dragon's also outfitted with 2 seats that you see there, and sitting inside those seats, we have 2 anthropomorphic test devices.
What, no cool acronym? I'll just call them test devices.
We have enough acronyms, John.
While the test devices do not have any sensors on them today, the seats they're sitting on are instrumented. We'll be able to measure the loads on the seat to ensure that there are no unexpected issues in this stressing test case. We've also made some other modifications to the Dragon interior for today's test.
That's right. There will be 3 cargo racks with some assortment of ballast or cargo bags and no floor. Now, below where the floor would be, there will be an assortment of mass simulators in place of the life support components and some other equipment that's down there when we have crew aboard.
Now, the test today will look a lot like a normal Falcon launch for the first minute and a half. We'll fly until Falcon 9 reaches a predetermined velocity. This will occur about 84 seconds into flight, and that happens at approximately 20 kilometers up. Once we reach the required velocity, Dragon will then trigger an escape. Now, as a reminder, the ground is not commanding this abort. It's up to the onboard computers to determine when to trigger the launch escape and do all the functions afterward. Once Dragon does trigger the launch escape, the first event will be commanding Falcon 9 to shut down its 9 Merlin engines. Now, as Marie and I mentioned earlier, Dragon will then separate from the Falcon using its 8 Super Draco engines, firing for about 8 seconds. That carries Dragon capsule with the trunk up and away from Falcon. Now, once they finish firing the Super Dracos, we coast, we jettison the trunk at apogee, we reorient the capsule to come back for entry into the Earth's atmosphere. We deploy about 2 minutes after apogee the drogue chutes, and about a minute after that, the 4 main parachutes will be released. Dragon will then splash down softly in the Atlantic Ocean about 35 kilometers offshore. Now, when Dragon separates, we no longer have that smooth aerodynamic shape on top of the rocket. So the supersonic Falcon is going to be exposed to strong aerodynamic forces in the upper atmosphere. So we expect those aerodynamic forces will cause Falcon to start to tumble. Our simulations show that the Falcon will likely break apart due to the tumbling, instead of having the destruct system triggered and destroying the rocket. So now again, this entire test will take less than 10 minutes from the time Falcon 9 lifts off until Dragon splashes down. But Marie, once we splash down, the work's not over yet.
Right, it's just beginning for the recovery team. We have a lot of things happening very rapidly in that first 10 minutes, and the recovery operation takes quite a bit longer. It'll be similar to the pad abort test, but it will happen slightly farther down range in the Atlantic Ocean. So after splashdown, recovery teams will already be standing by for range approval to enter and clear that hazardous area. And if all goes nominally, SpaceX could have fully recovered Dragon back onto its recovery ship approximately 2 hours after splashdown. Keep in mind, though, if this were to happen during an actual flight with crew on board, rescuing them would be the #1 objective, of course, and recovering Dragon would be a secondary operation. So if that were to happen, an elite military rescue team would deploy at a moment's notice. They're part of the U.S. Air Force's Detachment 3, or they have this really great nickname, the Guardian Angels, which is very appropriate. They would jump from military aircraft. There's a photo of that happening there where they would deploy their own parachutes to gently reach the water water, and from there they would help the crew out of the capsule and then onto a life raft to wait for a larger ship. Now, this is not just any life raft. It has a cover that they can put over the top to protect them from the elements, and it's also equipped with food, water, and medical supplies, enough to last for days if needed. This would be, of course, a worst-case scenario. It's one that we don't expect to happen. But of course, what do we do when we're preparing to fly crew? We always plan for the worst. So this is something that NASA, SpaceX, and the Department of Defense have rehearsed together over and over so that we're ready for anything.
And the SpaceX recovery team is also keeping an eye out for Falcon 9. As we mentioned earlier, Falcon 9 is expected to break up over the water. And we've got a dedicated team of SpaceX recovery personnel who will be staged and ready to begin recovering debris shortly after breakup. Well, the clock's kicking down rapidly. We're just over T-minus 2 minutes and 14 seconds from liftoff. You've seen the crew access arm. It's back. That was retracted away from Dragon at T-minus 42 minutes. A few minutes after that, Dragon launch escape system was armed just before we began loading propellant onto the Falcon 9. So if an unplanned situation arose right now, Dragon would perform an escape. Now currently the engines are chilled in for launch on the Falcon. The Dragon spacecraft is waiting for liftoff. We have retracted, and you can see in the video the strongback is moved away just about 2 degrees in readiness for liftoff. We have also finished loading liquid oxygen onto both the stages, so the Falcon 9 is just about ready. The large white cloud you see coming off of the side, we're venting down the pressure from the liquid oxygen supply lines in the strongback in preparation for launch. The last event you're going to hear, start up at 1 minute when the computers take over and the launch director go at 30 seconds.
And we're coming right up on that in about 15 seconds now. We'll be just a minute from liftoff. And Falcon 9 is, as you just heard, is moving into those final stages of the final countdown for the in-flight abort test today. So far, weather's looking okay. We're hoping it's going to continue to cooperate, and the range is green for launch. Now, if for some reason we scrub today, we will shift to our backup launch window, which is tomorrow at the same time. Again, this is just a test. We're fully expecting Falcon 9 to break up, so don't be alarmed if you see that happening live. And with that, let's listen in now. We're just 45 seconds from the final countdown.
FTS is armed. Go for launch.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff. Simplify, aim high. Go Falcon, go Dragon.
Vehicle is touching downrange.
T plus 30 seconds. Falcon 9 with the Crew Dragon capsule is heading east from pad 39A. Everything looking good right now. As we get ready for max dynamic pressure, we are now throttling down the first stage engines on the Falcon 9.
Power and telemetry nominal.
Everything continues to look good. We're approaching the period of maximum dynamic pressure.
Vehicle is supersonic and passing through maximum dynamic pressure.
You've heard we're supersonic. We're through max Q. We're getting ready now to throttle the engines back up on the first stage.
Stage 1, throttle up.
There's the call out. Okay, the major activity coming up in just over 10 seconds. Shutdown and Dragon escape from the Falcon 9.
Miko.
Dragon launch escape initiated.
Dragon's away.
And you can hear some really loud cheering in the room. Okay, you just saw a bright flash there. It looks like that may be Falcon 9 breaking up. We've got some loud cheers here in Hawthorne. The folks that just watched live the Dragon separate. The next milestone we have coming up at 2 minutes, 25 seconds, we're expecting to see the trunk jettison. So that claw that connects the trunk to the capsule is going to separate, allowing Dragon to separate from the trunk. That's coming up in 15 seconds.
And we do have the report, loss of telemetry from Falcon 9, first stage.
And there you just saw the trunk jettison. Again, some really loud cheers here in Hawthorne, California. This test is looking great so far.
Nice view from the back of the Dragon capsule. We're also trying to see if we get the view there on the right-hand side from the aircraft that's orbiting the area. Now the Dragon control system is now going to be reorienting the capsule. We're at a high altitude where the aerodynamics are negligible. So we're going to use the small Draco thrusters on the Dragon capsule to reorient it. That gets it in a position with a heat shield down to re-enter the Earth's atmosphere, and then later to deploy the drogue parachutes.
Now those drogue chutes, we expect to get confirmation that those have deployed at T plus 4 minutes and 48 seconds. So we've got just a little bit of breathing room before we hear that happen. Those parachutes are protected during ascent, on orbit, and re-entry by a panel that's up near the nose cone of the capsule. So we're going to jettison the panel, then the mortars will fire to deploy those 2 drogue chutes. Again, that's coming up in just over a minute at T plus 4 minutes and 48 seconds. Now those drogue chutes, when we see those come out, those will open, those will come out before the main parachutes. Those drogue parachutes are what we use to begin to decelerate the Dragon capsule in preparation for splashdown.
We understand we're getting into the drogue deploy envelope on the Dragon capsule.
We expect that will happen when Dragon is at about 20,000 feet. About 15 seconds to drogue chute deploy. And there they are. Drogue chutes are out. Again, some major cheering going on here as every stage of this test unfolds. Now we're going to be getting ready for the main chutes to deploy.
Now, main chutes will be coming up fairly quickly. There are 4 main parachutes. These are the newest Mark III parachutes. They're each 116 feet in diameter. We deploy them about 2 kilometers above sea level, 6,500 feet above the Atlantic Ocean. We're getting good views from the Dragon and the airplane, showing the 2 drogue chutes. Now we're just waiting for the main parachutes to be deployed very shortly. And we have the view from a different camera on Dragon showing the 4 main parachutes. Now they are deployed in a reefed condition. That means we're keeping them fairly shut to avoid shocks, and now we're slowly opening up the 4 parachutes. Great views coming off of the Dragon camera on the left, and we can also see the 4 parachutes from the airplane on the right.
That is a really cool view.
Nice view of the orange and white parachutes as they're opening up into the second position. And then going to fully open. From fully open, we'll be descending about 20 to 25 feet per second down to the Atlantic. So from that 6,500 foot altitude, it's going to take us a few minutes to splash down. Also right now that the mains are out, a sequence is performed on the Dragon, which will reorient the crew seats into a splashdown position, give them a little better angle to take the slow bounce as we hit the ocean. Now, Maria, I talked about the parachutes came out initially at a reef condition. That's fairly standard. They come out not fully open. That way they're minimizing the shock on the parachutes. We're also minimizing the shock on the capsule. Again, we want to give a smooth ride to the crew as they are coming back through the Earth's atmosphere.
Right.
Now, the parachutes are located behind a door that's at the bottom of the capsule. It's below the crew hatch. So Dragon commands the door to release, and as you saw in the video, the drag parachutes pull the door away, and that pulls the 4 main parachutes out. Now, these are the new Mark III parachutes. We've completed here at SpaceX over 80 tests of that parachute system, including 10 multi-parachute tests of this particular upgraded parachute design over the last few months to demonstrate that the design is ready for flight.
And we're just inside 2 minutes of when we expect to see splashdown. The recovery teams are already out there in the Atlantic Ocean standing by, ready with fast boats to begin their initial approach to Dragon. Again, we mentioned this before, but the recovery operation we expect to take a couple of hours.
I've heard a call out we're below 500 meters.
And we expect when Dragon splashes down, it's going to be roughly 32 kilometers offshore. Again, we're looking at a live view. So far, all things have appeared to go nominal for this test. All things looking great so far. We saw the 4 main parachutes deploy. You're looking at them now, fully open. And we are coming up on about a minute until splashdown.
I think we may have heard a call out of 100 meters to go.
Yeah, I just heard that too.
Yep.
Those 4 parachutes are actually going to be released from the capsule after splashdown, and they'll be recovered too.
And we are down.
Down a little bit early, in fact. And there you can see the recovery boat beginning to approach instantly. I'm going to try to talk a little bit louder so you can hear me over the folks here. This has been a really exciting thing to see because we had the weather. We weren't really sure if the weather was going to cooperate. We were trying to weigh, is it favorable for launch, but also is it favorable for recovery, because they really have to watch the height of those waves in order to do this operation. That fast boat is just off screen now, but there's 4 fast boats out there in the area to begin, again, that initial approach to Dragon. The recovery operation from here takes about 2 hours, but all in all, this looked like a really great test.
Yeah, a lot of fun watching the Dragon come down. We had great views from the onboard camera in particular. Now I think this camera is from our Go Searcher recovery ship, which is also the tender for the fast boats. You saw one of them headed out there. And you can also see it looks still a little choppy, so you understand.
motion in 3, 2, 1. Stop motion.
Another helmet camera view from Drew Morgan's helmet camera, which is helmet camera number 20. Another way you'll be able to tell the difference between the two spacewalkers today, and also by their spacesuits. EV1, Drew Morgan, will have the suit on bearing the red stripes, and Luca Parmitano will be in the suit with no stripes.
Okay, all the way to the VLI handle, fully open, and then back fully closed, cycled.
Okay, and based on what you did inside Space Station with the trainer, it looks like it's going all the way open?
Going all the way open means going all the way closed.
All right, thanks.
Okay, Drew and Luca, we're ready for that motion I described, 12 centimeters to Drew's left.
Copy. Copy.
Motion.
Motion.
That's your 12. For your next, it's going to be about 15 centimeters in the direction of your head.
Does that look, Luca? Okay, it looks good to me. I don't see any issues.
And Luca, for you, you'll be just continuing to check Drew's clearance to the AMS.
Copy.
Starting motion.
It's clear. Yep.
Now only one tube left to check for Luca Parmitano, and that is the view that we're getting from this helmet camera right now, helmet camera number 18.
And if you agree, we'll go ahead and do what will be about 40 centimeters body out at this time.
Okay, Christina, thanks for adjusting. It's now much better. And you'll go for body out.
Okay, thank you for that adjustment. And starting motion, 40 centimeters, body out. Okay, your next motion, up about 15 degrees.
Okay.
Motion.
Okay, your go, Luca. And we see you, Drew.
Okay, for number 6, VLI, fully open, no red.
Copy, good words, Luca.
Okay, I'm going to go ahead with 4.
Okay.
All right, fully open, no red. No, it was a very clean open, very easy. Okay, for number 4, 6.
Okay, understand that, Drew. Luca, we hear you're going to, you're wrapped up on 6.
Complete, and the MLI cover is down. And next will be number 7.
Copy, Luca. Drew, you can make sure all the MLI sleeves are secure. There's no metal showing anywhere. And then you can button that worksite back up.
And we just received confirmation that there were no leaks on the Nader worksite.
We, in addition to no metal showing.
Mission Control Houston, please call station for a voice check.
Space Station, this is the International School of Panama. How do you hear me?
To the International School of Panama, the International Space Station has you loud and clear. Welcome on board.
Copy. My name is Danny DePietro. I am a middle school science teacher here at the International School of Panama. We are a school of approximately 1,400 students from around 40 different nationalities. We also have some other schools here from Panama representing the entire country. We just want to say thank you so very much for spending your time and talking to us, as well as congratulations on your historic all-female spacewalk, and we wish you all the best with the rest of Expedition 61. I'd now like to introduce the 2 high schoolers who will run the Q&A. They are Jose and Paloma. And thanks again, ladies. You rock.
Let's welcome our first speaker, Red Jones, from kindergarten, our youngest inquirer.
For Christina, my question is, what does it feel like when you look down on your home country or town from space?
Yes, that's a wonderful question. And before I answer it, I just wanted to say hello to Danny and to all of you. Thank you for having us. And Danny, it's great to hear your voice again. It is indeed a wonderful feeling to look down on your hometown. I've had that great honor a couple times, and I'll never forget the very first time. I am from coastal North Carolina, and I remember, you know, the distinctive Outer Banks of coastal North Carolina kind of coming into focus the first time I saw them around the horizon of Earth, and it completely took my breath away. It was like looking at a map, except it was real, and I used all the same identifying features that I've used when I would look at a map to find my hometown and to see where I was from, and that
taxi! and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light.